Hi there, welcome to Eduretics, where we make your high school life simple. I'm Aniket, and this is the second and the last part of the SAT Math problem solving with DESMOS. So I hope you enjoyed the first video. You got to learn a lot of tips and tricks from the first video for solving the different systems of equations, linear inequalities, and other stuff. In this video, we're going to do even harder questions. And this is going to be even better. Let's begin. Okay, so 2x squared minus 4x is equal to t. This is the equation given to us. In the equation above, t is a constant. If the equation has no real solutions, which of the following could be the value of t? Okay, which of the following could be the value of t? So we don't need to find the specific value of t, which of them could be. So there might be a range. Okay, so two ways to do this. One is using the discriminant formula. Okay. So using the discriminant, that is b square minus 4ac, you can put it to less than 0 for no real solutions. But let's see how to do this quickly with DESMOS. 2x squared minus 4x is equal to t. Let's write that here. 2x squared minus 4x minus t equal to 0. That's the thing. That's like one and the same thing as 2x squared minus 4x is equal to t. Okay, so we take minus t here. Now for no real solution, basically this curve should not be cutting the x-axis at any point. Okay, at not a single point. Let's try to vary the values of t and see what happens. If I increase the t, it's going further down. That means it's ascertaining, it's establishing that there must be two roots. Let's reduce the value of t. Okay, let's keep on reducing and see where it converges. It looks like it's converging at x is equal to 1. Okay, and yep, it touches at x is equal to 1. Yeah, 1, 0. This is at t is equal to negative 2. So t must be less than negative 2 for no real solution. Less than negative 2. You see, it leaves the graph, it leaves the x-axis. So from now, like for all t is lesser than t is equal to negative 2, it's going to have no real solution. Okay, so let's look at the options. So t less than negative 2, there's only one option, option A, which is t is equal to negative 3. This is the correct answer. See, using DESMOS, we can see clearly why t should be less than negative 2. Okay, let's go to the next one. Okay, next question. This looks like a complex one. So square root of 2x plus 6 plus 4 is equal to x plus 3. What is the solution set of the equation above? Okay, let's solve this one. So just put whatever is on the left hand side, LHS, in one box, and whatever is on the right hand side in another box on DESMOS. So starting with the first one, so it's square root. For square root symbol, let's put it from here. Square root of 2x plus 6. So 2x plus 6 plus 4. This is the first one. Second one is x plus 3. Y is equal to x plus 3. Okay. Now let's change the visibility in order to be able to see this properly. Okay. And there's just one solution. They're intersecting at a single point, 5, 8. So x coordinate is 5 for the only solution to this equation. Okay. So option B is the correct one. Solution set has just one number, which is 5. Okay. Even if you solve this like manually, you'll have to square the right hand side and left hand side after sending the 4 to the right hand side. And then you'll be solving a quadratic. You'll be getting two solutions and you'll be discarding one of those because we have a square root also here. So only one value of x would be possible. So instead of doing all that, you can solve this in under 10 seconds on DESMOS. Okay, just like we did. Let's go to the next one. Next question. The graph of the function f defined by f of x is equal to negative half x minus 4 squared plus 10 is shown in the xy plane above. Okay, so it's a parabola opening downwards. It's a quadratic equation with x square coefficient as negative. If the function g, which is not shown here, is defined by gx is equal to negative x plus 10, what is one possible value of a such that f of a is equal to g of a. Okay, so essentially they're just asking the solution between this equation and this equation. Head straight to Desmos, just write them like that and see. So negative half x minus 4 squared plus 10, you don't even need to simplify it. Okay, so the first curve, y is equal to negative half. You can choose to write y is equal to or not, won't matter. Okay, x minus 4 squared plus 10, x minus 4 squared plus 10. That's the first curve. Second one, negative x plus 10, y is equal to minus x plus 10. Okay, there you go. There are two solutions possible. One is 2 comma 8, the other is 8 comma 2. Okay, like mirror image solutions. 2 comma 8, 8 comma 2. Mirror image about y is equal to x line. So one possible value of a, there would be two possible values of a, 2 and 8. Both would be correct. This is a grid-in question. Okay, so we can solve it in under 10 seconds like this. Okay, instead of solving it actually using the quadratic and linear equation solving. Okay, let's go ahead to the next one. The function h is defined by h of x is equal to a raised to the power x plus b, where a and b are positive constants. The graph of y is equal to h of x in the xy plane passes through the points 0, 10 and negative 2, 325 over 36. What is the value of AB? Okay, does this look like a question which can be done using Desmos? It may not be evident straight away, but you can try a combination of it. It's actually a difficult question, this one. Let's say h of x is equal to a raised by x plus b. We'll make use of a combination of Desmos and manual problem solving. So let's pick this first point, 0, 10. X is equal to 0, y is 10. If I put x is equal to 0, it's a raised by 0 plus b is equal to 10. A raised by 0 is a 1, b is equal to 10 minus 1, which is 9. The value of b is 9, that is certain now. So a raised by x plus 9. This is the curve which passes through 0, 10 and negative 2, 325 over 36. Okay, so now let's head to Desmos to see what we can do about this. So we have a raised to the power x plus b, where b is equal to 9. That we figure out from the given points. So a raised to the power of x plus 9. You can keep this function first. Okay, add a slider for a and give any random values. Okay, so now you have this. Okay, now we're given 2 points which lie on this graph. Let's put them here. Let's plot them here. So using the table option, the first point is 0, 10. Second is negative 2, 325 over 36. So 0, 10, negative 2, 325 over 36. Okay, these 2 points. Now you see, we need to arrange the graph in such a way so that it should accurately pass through these 2 points. So in that case, we'll be able to get the accurate graph which is asked in the question, the exact value of a. So let's try to fit these points. So 0, 10 is already fitting because we've already taken that into account and put the value of b as 9. Okay, so 0, 10, it's passing through. Now as a increases, it looks like it's passing through this point, the other one, negative 2, 1. Okay, at a is equal to 5.5, it's looking like it's passing. To be sure, make sure to zoom in. So now I'm going to zoom in and let's see whether it's actually passing or not. So when I zoom in, I see that it's actually not passing through that. Let's arrange the a further. So if I reduce the a, it's going away. Let me increase the a. 5.6, 5.7, 5.8, 9, 6. Okay, yeah. A is equal to 6 is the exact point where this is cutting. Okay, negative 2, 9.028. And if you solve negative 2, 325 over 36, let's check the value of 325 over 36. You can use the Desmos calculator directly. Over 36 is equal to 9.028. 0.777, that is 9.028. So we've got that point exactly. So a is equal to 6 is the answer. So the real function, the actual function is 6 raised by x plus 9. Okay, a raised by x plus b, that's 6 raised by x plus 9. So in our question, it's asking what is the value of AB, a times b. A is 6, b is 9. A times b is 54, 9 times 6. So option C. This is how you can solve this kind of a complex question also on DESMOS. Okay. Otherwise, manually, you'll be using this point. It can be solved manually as well. You'll be using this point and you'll be putting the values in the given expression to solve for the value of A. Okay, let's go ahead to the next one. Okay, next one, we have a table of x and y, the coordinates. The table shows 3 values of x and the corresponding values of y, where y is equal to f of x plus 4 and f is a quadratic function. What is the y coordinate of the y-intercept of the graph of y is equal to fx in the xy plane? So we're given the coordinates for y is equal to x, y is equal to f of x plus 4, and we're being asked about y is equal to f of x. Okay, the y coordinate of the y-intercept. So basically they're asking the y-intercept of y is equal to fx in the xy plane. And what is the y-intercept? So it's basically the value of y where the graph cuts the y-axis, or x is equal to 0. Okay. So first of all, let's convert this table for y is equal to fx instead of fx plus 4. So you just decrease these, like reduce these by a 4, the values of y. Because from the rules of transformation, you can see that this graph was raised by 4 units. So now the new graph or the new coordinates become -8. You bring this down, it'll become a -12. 23, 8. You bring this down by 4 units, it becomes a 4. Okay, and then x equal to 25, -8, you bring it down by 4 units, it's a -12. Okay, so from here, what we can see is at 21, it's a -12, and at 25, it's a -12. That means 21 and 25 are symmetric points. That means x is equal to 23 is basically the vertex, x coordinate of the vertex. And at 4, this is basically the coordinates of the vertex given to us. But instead of solving all this, what if I tell you the quickest way to do this through DESMOS? Okay, so you have 3 points given here. 3 points, 3 coordinates given here. Let's plot them quickly on DESMOS. Okay. I'm going to clear all this. Let's do a table. Sorry. You want to do a table. x1, 21 comma minus 12. Then x2, 23 comma 4, 25 comma minus 12, 23 comma 4, 25 comma minus 12. Okay, now this parabola is one which is opening, as we can see. Okay, 3 values of x are given. They just want to ask the y-intercept of this y is equal to fx. So let's directly plot y is equal to fx. How do we do that? Just like you did regression for the lines, we'll do regression for the quadratic equation. y1, put a tilde or the wavy mark. y1 is b0 plus b1 x1 plus b2 x1 squared. This becomes the quadratic equation. Okay, so we have b0 is equal to -2, 1, 1, 2. What is b0? b0 is the y-intercept, because if I put x is equal to 0 in both these places, we're just left with y is equal to b0. That is -2, 1, 1, 2. Here's the answer in front of you directly, -2, 1, 1, 2. Effectively, it won't take you more than like 20 seconds, hardly 20 seconds, -2, 1, 1, 2. That's the answer. This is a grid-in question. Okay, I just took time to explain it to you, but you can directly do the regression and find out the quadratic equation. Okay, let's go for the next one. Okay guys, a word of advice to every one of you. You might be getting tempted to do all questions using DESMOS, which is actually good if it saves time, but there would be questions which can be done quicker when done directly or manually. So make sure you do the right judgment for that. Okay, let's look at this question. The total distance d in meters traveled by an object moving in a straight line can be modeled by a quadratic function that is defined in terms of t, where t is the time in seconds. So distance d in meters, that is on the y-axis, and the time t in seconds. At a time of 10 seconds, the total distance traveled by the object is 50 meters at 10 seconds. At a time of 20 seconds, total distance traveled by the object is 200 meters. If the object was at a distance of 0 meters when t is equal to 0, then what is the total distance traveled in meters by the object after 30 seconds? It's a specific quadratic equations question with a lot of values, but let's see how we crush it using DESMOS. Okay, as you can see, simply, there are points given. This is distance d in meters, this is on the y-axis, and this is time t in seconds. So at 10 seconds, it's 50 meters, at 20 seconds, it's 200 meters, and at 0 seconds, it's 0 meters. We're given 3 points. Let's straight away go for a quadratic equation. Okay, let's go to DESMOS. We'll input a table. Okay, 0, 0, that point I already remember. Then at t is equal to 10 seconds, it's 50. T is equal to 10, it's a 50. T is equal to 20 seconds, it's 200 meters. 20 seconds, 200 meters. Okay, let's join these points. Okay. Oh, we don't need to join these points. Why? Because it's going to be a quadratic equation. If we join these, it's going to be a straight line, simply a straight line, which we don't need. Okay. So I'm just removing it here. Okay. Now let's do the regression. So y1 is equal to b0 plus b1 x1 plus b2. This is the coefficient of x squared, x1 squared. Let's remove the equal to sign. You might be making this mistake a lot because even I do after so much practice. So just be very careful to put in the tilde sign instead of the equal to sign. Okay. Now let's look at the graph. It's right here in front of us. And what are they asking? Distance traveled in meters or by the object after 30 seconds. Simply put, x is equal to 30. So let's zoom out in order to be able to see the answer easily. X is equal to 30. Let's see where does it meet the graph. Okay, and this is the point, 30, 450. So total distance traveled is going to be 450 meters at x equal to 30 seconds, like after x equal to 30 seconds. So the answer is 450 meters. This would have been a very long question with too many calculations, but now it's nothing. 450 meters at 30 seconds. This is the answer. Okay, let's go for the next one. Okay, next question. This is a difficult one. H of x is equal to x cubed plus ax squared plus bx plus c. We are given a cubic equation. The function h is defined above, where a, b, and c are integer constants. If the zeros of the function are -5, 6, and 7, what is the value of c? Okay, how do you do it? Mathematically, if you were to do it like manually, you would simply say x plus 5, x minus 6, x minus 7. You multiply all these. Whatever you get, you set that equal to x cubed plus ax squared plus bx plus c, and then you open these brackets, like multiply, open these brackets, compare the coefficients, and then finally whatever constant term you're left with, you'll write that here. With DESMOS, how do we do it? What is the meaning of zeros? Zeros means these are the values of x at which y is equal to 0. The function's value is equal to 0. So we already have 3 points given to us. Let's go to DESMOS and do the regression. This time we're going to do a cubic regression. Okay, so let's put in the table, and we have -5, 6, and 7. X is equal to -5, it's a 0. X is equal to 6, it's a 0. X is equal to 7, it's a 0. Okay, these points are given. Now, it's x cubed plus ax squared plus bx plus c. So there's one extra information given to you. 3 points were required for a quadratic regression because a quadratic equation has 3 coefficients, b0, b1 and b2. Basically the x squared coefficient, x coefficient and the constant term. In our case, it's a cubic equation. That means 4 coefficients, but we're given only 3 points because there's one extra information given, the coefficient of x cubed. That's given to be 1. Okay, so let's put that here. Let's do the regression. y1 tilde is equal to b0 plus b1 x plus b2 b1 x1 b2 x1 squared, okay, plus x1 cubed. b3's value is 1, x1 cubed. So you see b0 is coming out to be 210, b1 negative 23, b2 negative 8. All values are here, a, b, c values are here. So they were asking us for the constant term. So basically x cube coefficient is already known, x squared coefficient, x coefficient and constant. We need the constant. So the constant is b0, b0 is 210. Simply 210, that's the answer. DESMOS can simplify things to this extent, guys. You might be tempted to do the hardest of questions using DESMOS. That's actually good. So using regression, you can possibly graph anything at all. Anything given on your SAT test can be graphed very accurately with the equation and with the coordinates on DESMOS. Okay, let's go to the next one. Next question, we're given 2 equations. One is a quadratic, one is a linear. How many solutions are there to the system of equations above? Okay, head to DESMOS, graph the equations. X squared plus 3x minus 7 plus 3x minus 7. There's one, and y is equal to 5x minus 8. 5x minus 8. Let's see how many solutions we have. So for that, you click on the blue line. It'll show you how many points it's touching on for this one. Okay. So let's check that. Just a single solution. As you can see, it's going to be 1 comma negative 3. And now if you zoom out and see if there are any other points of intersection, there are none. The graphs are diverging on both the sides. Just met here, 1 comma 3. So there's just one solution, exactly one solution. This is the correct answer. Okay, so that was quick. Let's go for the next one. A quadratic function models the height in feet of an object above the ground in terms of the time in seconds after the object is launched off an elevated surface. The model indicates the object has an initial height of 10 feet above the ground and reaches its maximum height of 1034 feet above the ground 8 seconds after being launched. Based on the model, what is the height in feet of the object above the ground 10 seconds after being launched? Okay, a very interesting question and a classic one for DESMOS. So it's saying initially it's at a height of 10 feet above the ground. So at t is equal to 0, the height is already 10 feet. Okay, and at t is equal to 8, it's at the maximum point, which is 1034. At t is equal to 10, they're asking us. Okay, so at t is equal to 10, we don't know the height. As you can see from the given data, the quadratic function is actually going to be one with a parabola opening downwards. So the coefficient of x squared is going to be negative. Okay, a is going to be negative. Let's look at the DESMOS graphing calculator and see how we can graph this accurately. So let's pick these points and plot them here. X is equal to 0, y is 10. The height was already 10. At x is equal to 8 seconds after, it has 1034. The height is 1034. Okay, and this is the maximum point. Now the object 10 seconds after being launched. So let's write this. We'll write a regression for this one. Let's write the regression. y1 tilde b0 plus b1 x1 plus b2 x1 squared. Okay. We write always in terms of x1 and y1. Now, as you can see, b2, the regression is giving the value of b2 as 0 because we've just given these 2 points, and based on that, the DESMOS regression calculator is guessing that it's a straight line instead of a quadratic equation. So what do we do for this? We apply a small trick here. Okay. Look at the question. It's going to be a quadratic of this kind. We know the coordinates of this point. Okay, that are 0, 10. We know the coordinates of this point. It's 8, 1034. According to symmetry, this last point should be 16, 10. It'll be at the same y value as the starting point, and since 8 is the midpoint of the start and end, so after the stone, or basically the object, the object's journey would continue for 8 more seconds after the maximum point. So let's put this point also in the regression, 16, 10, and then we'll get the correct one. So x1 is, let's change this. We'll put a new value. x1 is 16 when y1 is 10. Now let's do this. y1 tilde b0 plus b1 x1 plus b2 x1 squared. Now you're getting it. Now when we look at our graph, it's going to be a quadratic, a parabola opening downwards. As you can see, the tip is coming somewhere here. 1034. Now what are they asking us? At x is equal to 10, what is the height in feet above the ground? So simply do x is equal to 10. Let's find a point of intersection between this graph and x is equal to 10 line. It's right here, 10, 970. So it's 970 meters above the ground. Straight up, the answer is right here. Okay. X is equal to 970. It's 970 meters. Okay. So keep practicing. I'm telling you, any kind of toughest question can easily be solved using DESMOS and regression. Okay. So let's go for the next one. Okay guys, so share with as many friends as you can, as many test takers as you can. This is literally going to blow up, and people are going to benefit from this a lot. I've put in a lot of effort to figure out these tricks, these concepts on which can be used to solve the complex problems through DESMOS in under 30 seconds, 20 seconds, like that. Okay. So make sure you share with as many people as you can, and make sure you practice and understand this properly. Okay. So that you go cracking on your main exam. Okay, thanks. Bye-bye.